Hi guys, in this screencast we're going to talk a little bit about water and why water is so important in biology because um, a lot of times, you could ask a first grader what's the most important liquid on earth, and they could probably tell you it's water. But we're going to go a little bit deeper than that and actually talk about some characteristics of water and why those characteristics give water the properties that make it so vital for life. So to do that, the first thing we're going to do is do a quick review of the structure of water and kind of how the atoms are arranged. All right. So we're going to start out the amazing properties of dihydrogen monoxide, or water, as we commonly call it. All right. So we remember that water is one oxygen and two hydrogens. And from earlier lessons, we talked about how the oxygen has 6 valence electrons and the hydrogens have 1. And oxygen wants 8 and hydrogens wants 2. Each hydrogen wants 2. So if we show that, here's your oxygen, and there are 6 electrons. 1, 2, 3, 4, 5, 6. So there's 2 spots here where hydrogen can attach, and here's your hydrogen, and here's a hydrogen, and hydrogen has 1. So what happens is these electrons, it's 1 electron comes over here and they form a pair, and this 1 electron comes over here and they form a pair. And what do you know? Now the oxygen has 8. Which is exactly what it wants, and each hydrogen has 2, which is exactly what it wants. So therefore, since they are sharing these electrons, since they share these pairs of electrons, it's called a covalent bond. So water is bonded, the oxygens and the hydrogens are covalently bonded to one another. Now, one quick thing with this, though, water, the electrons are not shared equally, okay? And the reason for that, let me erase this real quick. Let's see here. The reason that the electrons are not shared evenly is because the oxygen atom, oxygen has 8 protons. So let's look at this, 8p plus, right? And hydrogen only has 1 proton in its nucleus. So basically what happens is the electrons that are being shared and floating around these atoms, they're not in the middle, okay? They're going to be, since the electrons are negative, they're going to be pulled towards the positive protons. And since oxygen has 8 protons in its nucleus, the electrons are going to be pulled closer to that oxygen. So a quick example of that is, let's say that you have 8 people over on this side. They're all the same strength, and you have 1 person over on this side, and all 9 of these people are the same strength. If you have a rope in the middle and they're both pulling, and this dot represents the center point, so let's say this dot represents the electrons. If all of a sudden both these sides pull, obviously where are the electrons going to go? They're going to go towards the 8, right? Because there's a stronger pull in that direction. So since the electrons get pulled in that direction, that leads to a really important word that we're going to talk about, and that leads to water being what we call polar. Really important word, okay? And basically what polar means, polar just means that the oxygen, because the electrons are slightly closer, has a slightly negative charge. Not a strong negative charge, but it's slightly negative. And your hydrogens, which will show coming off of here, and will show coming off of here, because the electrons are further away, they have a slightly positive charge, because remember, electrons are negative. So since the electrons hang out closer to the oxygen, oxygen is negative. And since those negative charges are further from the hydrogen, hydrogen is then positive. So that makes water polar. Basically, the different sides of water have a slightly different charge, and that polarity is extremely, extremely important. So on this next slide, you can kind of see what I'm talking about here. You can see that here is the oxygen, and you can see that the electrons, instead of being in the middle here, between the two, evenly shared, they're closer, they're being pulled closer to that oxygen. And again, that means oxygen's going to have a negative charge, and you can see that up here, and your hydrogens are going to have a positive charge, and you can see that right here. Again, really, really important. The fact that water is polar is extremely, extremely important, because what that polarity does, it allows for a special type of bond, a bond that is not, that a lot of other liquids can't make. And this is basically the bond that makes water so important for life, makes water the liquid of life. So if we, again, let's say we have two water molecules here, slightly negative, and these are slightly positive. So what happens is, if I have another water molecule up here, what do we know about opposites? What have we learned so far? The opposites do what? They attract, right? So basically what happens is, when you have all your water molecules together in, let's say, a droplet, or let's say in blood, which is made mostly of water, or let's say the water flowing up the tubes of plants in the xylem, what happens here is the positive hydrogen, slightly positive hydrogen, and the negative oxygen, slightly negative oxygen, they form an attraction, because opposites attract. So they form, I'm going to show it here with these dotted lines. They form what's known as a hydrogen bond, H bond, we're going to call that. And these H bonds, let me fix that quick. That's a D. These H bonds, these hydrogen bonds, this attraction between water is really, really, really important, because this attraction between water molecules is what makes them stick together, and then because they stick together, it gives them characteristics that no other liquid on Earth that we know of anywhere has these same capabilities as water. It's important for maintaining homeostasis. It's important for water flowing through organisms. It's important to make ice float on top of water. And we can talk about, and we're going to talk about in the next video, what exactly this means in terms of the actual characteristics that are formed as these hydrogen bonds form. So this quick picture, I didn't want to do that. This quick picture here, this is basically a kind of showing you the hydrogen bonds that are forming between these molecules. And one hydrogen bond is weak, but when you have a drop of water, when you have more than one hydrogen bond together, it's much stronger. So this attraction between these atoms can become quite strong, and is again really, really vital for life. So hopefully through this video, you got a quick review of how water molecules are put together, and the electrons and the hydrogens, and And hopefully you understand a little bit about because the electrons are closer to the oxygen, it makes water polar, and then hopefully you understand how that polarity of water forms a really, really important bond in biology called the hydrogen bond. So next video we'll continue there and talk about some of the actual characteristics that the hydrogen bonds allow. Thanks very much. Have a good night.